So again, this is a test question. It's page 32, number 7. Again, I'm just looking at just C. Just C for this one. On the test, I'm actually going to draw the picture for you. You won't have to draw the whole picture. But the idea that I want you to get at is being able to use variables when you're angle chasing. So right here what they're saying is we have a triangle ABC. Okay, I'm not going to draw it like I do a typical triangle. Let's go A. You know what? I never draw an obtuse triangle. Let's try that. And all I got to make sure is that A has a 34-degree angle. So I'm going to do A, 34-degree angle. Then I'm going to go B and C. Now the bisectors of angles B and C meet at point I. So I'm going to bisect B. So now these are equal. And I'm going to bisect C. So now these two angles are equal. And they meet at point I. Now the question is find what point I equals, or BIC, what angle BIC equals. So put a little question mark there. Yes?
How did you find that spot for I? Like, how did you find, for C, how did that line get onto?
To I?
Yeah, like, how did you figure out where that was going to go?
So what I did was I looked at, because it's asking you for the bisectors, I just bisected angle B, and I'll make it in a little green here. So I bisected angle B and just extended it to make these two equal. That's all I cared about, was those two being equal. That bisects it. And I did the same thing on C. I'm just going to extend C so that I'm cutting C's angle in half. So I cut C's angle in half. That was what I was looking at. And they just happen to meet at I when they're both cut in half. Okay? So that's what we're looking at there. Okay, so we want to figure out what angle I is. Does anybody remember what we did on the first time we tried this problem? I think it has to do with putting some x's in there. Okay, so let's look at angle B. Let's call this whole angle B, and this is what we just did a second ago. Let's call that x. All right? If that's x, what would angle AB or ACB be? What would that be?
34 minus x.
Right, so not 34 minus x.
X minus 34, sorry.
Not x minus 34.
180 minus 34.
Yeah, don't forget the 180.
Oh, okay.
So we have the 180 minus 34 plus x. Or you can just say 180 minus 34 minus x. Either way, you still get, so it's or 180 minus 34 minus x. So either way you get for that part, that is 143 minus x. Should I put that in here? Let's go here. 143 minus x. Okay, so if that's 143 minus x, let's use like pink or something. I haven't used it. If this angle ABC is x, so this angle right here, that's x, what would angle IBC be? What's that?
I don't think it's 143, I think it's 146.
Or that, if you did correct math, arithmetic's very important, and of course now it won't let me erase. So, error, 146 minus x. Beautiful. Okay, that's great. Okay, so let's go back to this idea right here of this angle, the pink angle right there. What would that angle have to be? 1/2 x. I'm going to call it x over 2. You okay with that?
Wait, isn't that just the green angle though?
It is the green angle, yeah. But the reason I'm doing this is because I want to find angle I right here, BIC. So I'm going to look at this small triangle at the bottom. Okay? So if that's x over 2, what would this angle over here have to be? What's that? So yeah, that would be 146 minus x over 2. Everyone okay with that? And then we have angle I. I'll just call it angle I. It's BIC. But we have angle I that we want to find. What do I know about those three angles?
Or something.
They're supplementary. They add to 180. So they have to add to 180. So I'm going to throw some plus signs in here. I'm actually going to attempt to do this. Right there. And then if we do some algebra here, we have that x over 2. Well, if we combine that now, we'll have x minus x over 2 minus x over 2. Does that make sense? So I can split all these up if I wanted to. Everybody see I can split that up like that? And then go plus. So this was on page 33, number 7. And it's kind of interesting because we have this picture that doesn't have any angles in it at all. And it says to find the angle C. So we want to find what angle C is. And I remember this one we did earlier. That's angle C right there. So this one we did earlier, and we did it a few different ways. So let me hopefully zoom in here. There we go. Okay. So we want to find angle C. So does anybody remember the first thing we did to just start chasing some angles around?
We made B and C and BAC, we made them all X.
So we put in an X for a angle. And it'd be nice just to use the angle, and I don't think we did this, but let's use the angle that we are trying to find. So let's call C, call that X. Okay. Do we have any other angles that would be X now?
B
Angle B would be X.
and angle BAD.
Right, because this is an isosceles triangle right here, because angle BAD is isosceles, and then these are the equal sides right here, that means that this also has to be X. Right there. Okay, so if that's X, can we find maybe this angle right here? How do we find angle BDA right there? 180 minus 2x. So we go 180 minus the two other angles, so 180 minus 2x. Okay, so now can we find what angle ADC would be? Right there.
Negative 2X.
Close. We are going to go 180 minus 180 minus 2x. That makes sense? So it's actually a positive 2x. So we're going to put a positive 2x here. And again, the reason is because I went 180 minus 180 minus 2x because of the linear pair.
Couldn't you have just added X and X together?
Could do that too. We could do exterior angles. And the remote exterior angles, or the exterior angle right here, is always equal to the two remote interior. So these added together is another way to do it. Okay, so is there, that last angle we don't have, can we find that?
Isosceles.
Right, that's an isosceles triangle, so that would be 2x. Okay, now what can we do to solve for x?
Add them all up and so they equal to 180.
Add all of our exterior angles up. So I'm going to add up x plus x plus, and then I have this up here. That's 3x, right? I'll just put x plus 2x. That equals 180. We get 5x equals 180. X equals 36 degrees, and we're done.